Hello friend, welcome to our channel Competitive Data. In the previous class we discussed up to question number 16. Now we discuss from question number 17. Question number 17 is a metallic rod of length 1 meter and diameter 1 centimeter is subjected to uniaxial tensile force of 2000 kN, result in an increase of length of 1 mm and reduction in diameter of 0.028 mm. We are find to the Poisson's ratio. So the calculation will be given length 1 meter, diameter 1 centimeter, that means 0.01 meter, and our load is 2000 kilonewton, that means 2000 into 10 to the power 3 newton, and change in the length is 1 into 10 to the power minus 3 meter, and change in diameter is 0.028 into 10 to the power minus 3 meter. That will minus sign indicate that there is a decrease in diameter. So we know the formula. Poisson's ratio is lateral strain by longitudinal stress. Lateral strain means we are decreasing the diameter. That means change in diameter divided by original diameter, whole divided by change in length divided by original length. Here the diameter is decreased, so we indicate the negative signs. So minus of minus 0.028 into 10 to the power minus 3 divided by the diameter is 0.01 meter divided by whole divided by change in length. Change in length means 1 into 10 to the power minus 3 meter divided by original length is 1 meter. So after calculating this value, we get 0.28 Poisson's value. As Poisson's ratio has no unit, so simply 0.28. So option A is the correct answer for the question number 17. In the next question, 18 number, a circular shaft of diameter d is subject to torque T. The maximum shear stress induced in the, what is the maximum stress? The question asks. So options are 32T by pi d2, 16T by pi d2. Option C 16T by pi d square. Option D 32T by pi d square. The answer will be, in the explanation we get, answer will be tau max is equal to 16T by pi d2. The explanation is, we know the formula, shear stress equation, tau by r is equal to T by IP. IP is polar moment of inertia. So implies that tau max divided by maximum radius is r, capital R, is equal to T max by polar moment of inertia. Tau max is equal to T into r divided by pi by 32 into T 4. As polar moment of inertia of the cylinder, we know pi by 32 into T to the power 4. So T into capital R value d by 2 whole divided by pi by 32 into d4. After calculating, we get 16T by pi d2. So option B will be correct answer. 16T by pi d2. Next question, question number 19. A thin-walled cylinder closed at end is filled with fluid to a gauge pressure P. If D and T are the diameter of the cylinder and the thickness of the wall, the maximum normal stress induced in the wall in the cylinder. So we are finding to maximum normal stress. So in conclusion, we know the hook stress is PD by 2T and longitudinal strain is PD by 40. T thickness, D diameter, P is the load. Pressure, gauge pressure. So we know the maximum stress, sigma H plus sigma L divided by 2 plus root over of sigma H minus sigma L by 2 whole square plus 0. 0 means shear stress is 0. So by putting the value PD by 2T and PD by 40, we finally get the answer PD by 2T, which is option A is correct answer. So PD by 2T, option A is correct answer for question number 19. Next question. The ratio of buckling load for a long column pinned at both the end to the buckling load for the same column if the ends are fixed. So the explanation will be question number 20. We know the buckling load formula is pi square EI by LE square. E is Young's modulus, I is moment of inertia, LE is equal to equivalent length. We know for both the end pins for the equivalent length is L, simply L, and when the both the ends are fixed, equivalent length is equal to L by 2. By putting the value L is equal to L for both the end pin and L is equal to L divided by 2 for both the end fixed. After cancelling all the value, equivalent of 1 divided by equivalent of 2, we get 1 by 4. So option C will be correct answer. Question number 20. C will be correct answer. Next, question number 21. For uniform circular cross-section of road subject to uniaxial tensile load P, the strain energy stored in is E. If the load is reduced to P by 2, the strain energy stored will be what amount will be strain energy reduced if the load is decreased to P by 2. So explanation will be 20 number 1. We know strain energy is equal to half P square L divided by AE. So if the load is decreased to P by 2, that means if the new load is equal to P1 by 2, so after putting the value P2 is equal to P1 by 2, we get E by 4 as P square as a strain energy directly proportional to load power square. So the strain energy will decrease the power of 2. That means if half decrease, then half power square will be decreased. So strain energy will decrease by amount E by 4. So option B will be correct answer. After calculating, you can get this answer P by 2. So in question number 21, option B will be correct answer. Next, question number 22. Two closely coiled helical springs S1 and S2 are identical in all respects, but the number of active turns of spring S1 is half that of spring S2. The ratio of deflection in spring S1 to spring S2. In the question we get deflection formula we know 64 RQN W divided by GT to the power 4, where capital R is coil radius and small d is the diameter of wire. This is the radius of the wire and this is the diameter of wire and this is the radius coil. So in the formula deflection of spring, deflection is directly proportional to number of active coil. From question we get S1 is half of that S2. So spring 1 is the number of coil in S1 is a half of S2. So N1 is equal to half of N2. Deflection 1 divided by deflection 2 is equal to half divided by 1 is equal to half. So deflection will be decreased by half amount. So option A will be correct answer. In number 23 question number, at the neutral axis of cross section of a beam subject to bending, the bending stress will be. At neutral axis we know the bending stress is 0. So option B is correct answer. Next question number 24. On principal plane the shear stress. We know on the principal plane shear stress is 0. So option A is correct answer. When a preloaded only is applied to bolted joint, then the force developed in. So we know the answer will be compressive force, because we apply the force in tensile direction, there will be a reaction that will be compressive. So this answer will be compressive force. So in question number 26, the margin in a rivet joint is distance between. Options are the edge of the plate to the center of the any rivet. Option B, the center of any rivet to center of adjacent rivet in the same row. Option C, to consecutive row of rivet in the same plane. Option D, the edge of plate to the center of the rivet that is close to edge. So option D is your correct answer. The margin is the edge of the plate to the center of the rivet that is close to edge. That will be more accurate answer, and this is the right answer. So question number 26, option D is correct answer. Thank you. In the next class we discuss the remaining question from question number 27. So thank you.